In this video, I'll introduce some advanced topics in one-point perspective, and it's in my art instruction course on Amazon. How would we find these box flaps? Well, we first have to find the central vanishing point where the sides of the box meet, and that central vanishing point is on eye level. Then for the flaps, they either converge toward a vanishing point on eye level, as do these green flaps, or they converge on a line that's above or below the central vanishing point, like these blue flaps. These figures are the same size because they lie within the same converging lines, so they're about 5.5 feet tall, and their eyes are a little higher than eye level, indicating that they're taller than the viewer. Now, this pink person will be the same size as the yellow one because the heads and the feet line up. And the blue one is going to be as big as the green one, because if the green one weren't standing on the bureau, she would be right here, so she would be in line with the feet of the blue person. To find the size of figures distributed around a room, draw converging lines to the wall so that these vertical lines are the same size. In the second case, the red rectangle and the green one are the same size because they're on the same converging lines. And so if you want to find the size of the blue one, it's the same as the green one. You just lift it up so it's on top of the box. Let's draw a room that's parallel to the picture plane, meaning it has true horizontal and vertical lines. So start with this large rectangle and choose a vanishing point on eye level that's slightly to the left or right of center, so that one side of the room, here the right side, is a little bigger than the left side. Then draw this rectangle in the back, touching the same converging lines. Any part of the box, like the window, converges toward the room vanishing point, as do boxes like this red one that is aligned with the room. This box, which is not aligned with the room, goes to a different vanishing point. Now, where do we put the door? The door is about 80% up the wall, and eye level hits the door usually about 3/4 of the way up for a standing adult. So then, now that we have the top of the door, bring that line over to the edge of the room and then draw the converging line, and in that way you'll identify the top of the window, since usually the tops of windows and doors align. To find angles in perspective, draw a line from the center of vision to the eye, and then from the eye to D45, forming a 45-degree angle with the horizontal and vertical lines. Then, any angle converging toward the center of vision and D45 produces a 45-degree angle in perspective. In a similar fashion here, I made a true right angle with the blue and orange pens at the bottom of this diagram, and the eye would be about right here. This gave me two D45s because this is a 45-degree angle, so this is one D45, and this is the other D45. I'm not using the center of vision, which would be vertically above the eye right here. Then I took pictures of the pens at forming various angles, and the pens always pointed to the two D45s, meaning that they are true right angles in perspective, as is this one. Another way to find angles in perspective is to draw a triangle here with a right angle and have a point on a circle where the blue dot is the center. If this angle were less than 45 degrees, the circle would be bigger. This blue triangle shows the true angles because two of its sides are parallel to the picture plane. In other words, they're horizontal and vertical. Any triangle sharing this edge with a point on the circle has angles in perspective. So angle 1 is a 90-degree angle in perspective, and angle 2 is a 45-degree angle in perspective. My next video will be forming grids in one-point perspective, and please remember to subscribe.